So hello everyone, as you already know, this is Gayathri Shivakumar. So in this video, I'm going to speak about the chapter optics. So what is optics, everyone? Optics is nothing but study of light, right? So light is nothing but it is a form of energy which always travels in the form of waves. Okay, this path of light is called as ray of light, and group of these rays are called as beam of light. For example, when sunlight will share some rays of light, right? So in that case, a group of rays of light is called as beam of light. Okay, so any object which gives out light as termed as source of light. Some of the sources emit their own light and they are called as luminous objects. All these stars, including the sun, are examples for luminous objects. So luminous objects are objects which emit the light of their own, which produce the own light. Okay, that is called luminous objects. We all know that we are able to see objects with the help of our eyes, but we cannot see any objects in the dark room. Can you explain why? If your answer is we need light to see the objects, and my next question will be like, if you make the light from a torch to fall on your eyes directly, will you able to see the objects? Definitely no, right? We can see the objects only when the light is made to fall on the objects and the light reflected from it is viewed by our eyes. Yes, no? That's correct. Okay, so in this chapter we'll be discussing about scattering of light, images formed by convex and concave lenses, human eye and optical instruments such as telescopes and microscope. So let's move on to the first topic, that is properties of light. So as I said, light is a form of energy. Light always travels in a straight line path. Light does not require any medium for propagation. It can even travel through vacuum. The speed of light in vacuum is 3 into 10 to the power 8 meter per second. Since light is in the form of waves, it is characterized by these factors. First one, lambda, that is wavelength. Second one, frequency, that is denoted by the letter mu. And the following equation will be like C is equal to mu lambda. The C denotes the velocity of light. Now we are having lot of colors like VIP, G, or correct. So different colored light has different wavelength and different frequency. Among that, violet color has the lowest wavelength and the red light has the highest wavelength. When light incident on the interface between two media, it is partly reflected and partly refracted. So the next topic will be like refraction of light. So refraction of light, let us start with an example. Let us take a beaker which is filled with water and a pencil is dipped into the beaker. It is seen left, okay? In that case, what do you observe? Will the pencil be straight when you look outside, or it will be like looking bent? Yes, you're obviously correct. The pencil will be looking bent. This is due to refraction. So what is called refraction? According to physics, when a ray of light travels from one transparent medium into another, the path of light undergoes deviation. This deviated ray is called as refraction. For example, the same example we'll take, that is pencil, the half of the pencil will be in air medium and remaining half of the pencil will be in glass medium. When the pencil is dipped into a beaker of water, when it is dipped into the beaker of water, so what will happen? There will be two different mediums and the path of light will be undergoing some deviation. That's why the pen appears to be bent. Okay, so this is called as refraction. The velocity of light is more in rarer medium and less in denser medium. Refraction of light obeys two laws of refraction. First law of refraction. The incident ray, refracted ray and the normal ray all lie in the same plane. Second law of refraction is otherwise called as Snell's law. The ratio of sine of angle of incidence to the sine of angle of refraction is equal to the refractive indices of the two media. Sin I by sin r equal to mu2 by mu1. The refractive index gives us an idea of how fast or slow light travels in a medium. The ratio of speed of light in a vacuum to the speed of light in a medium is defined as the refractive index of that medium. The speed of light in a medium is low if the refractive index of the medium is high and vice versa. So therefore, I conclude speed of light is inversely proportional to the refractive index of the medium. So